Well, hello everyone, and welcome back to Prep32. So on the prior tab, we had the population data and the data for only one sample. On this tab, we have information about the population, standard deviation and mean, but not the population data. And when someone just knows what the standard deviation and mean are, and that turns out to be good enough. We also have the data for one sample, which is here. So a local TV station recently conducted a random sample of 40 local gas stations to find their price for a gallon of regular gas. The national population mean is 376 per gallon, and the population standard deviation is 55 cents. Calculate a z-score and determine the probability of observing the sample mean. So let's frame the problem. So the problem is finding the probability below x. So the case is going to be one tail left. And the function that we're going to use is norm.dist. Oh, sorry, norm.s.dist. The reason for norm.s.dist is because we're calculating the z-score first, then the probability. All right. So from the problem, right? From the problem, in fact, you not even have to type it because we sort of gave it to you. From the problem, we know that price of gas is $3.76. There it is. From the problem, we know that the actually, by the time I distribute this, I might make you type these. But from the problem, we know that the standard deviation is 55 cents, and from the problem, from the central limit theorem, we know that this mean has to equal this mean. The sampling distribution mean has to equal the population mean. So let's get the ones that we don't know. So the x bar is the average of these, and the standard deviation of the sample is this, and then the standard error, or but effectively is the standard deviation of the sampling distribution, is equal to sigma divided by the square. Oh, I can't do it yet. Keep messing up. We need to know the number of records in the sample, so let's count those. Okay, now we can do it. So it's going to be equal to sigma divided by the square root of n. All right, so let's look at our picture. So here's our population. These are the original gas prices. Our sample gas price is right here at 354. So basically we're asking ourselves the question is, how likely is it that a sample of 354 comes from a population where the average gas price is 376? And then here's our sampling distribution to help us answer that question, because basically it's where we fall on the sampling distribution that determines how likely or unlikely this is. This looks kind of unlikely because we're sort of already here in the tail of the sampling distribution, but we'll get more of a feel for it when it gets plotted down here as soon as we answer the next couple questions. So we'll look at x bar minus mu. So here's x bar minus mu, and then the z-score is the observed difference, which is what we just got, divided by the expected variability, which for the sampling distribution is this guy. And then the probability of getting a z-score like that is norm.s.dist that and true. All right, that's pretty low probability, 0.6%. You can actually see it graphed here. So probability here it's shown as 0.64, but it's the same. And then there's the z value of negative 2.49. So we're in the green area. When you're in this green area, statisticians would say, hey, maybe that sample didn't really come from the population, right? Maybe that sample is representing a different population. And we'll talk about that more in our next unit. Okay, so let's come over here. What is the sampling distribution of the sample mean? Distribution of all possible sample means of size x bar. Why is the standard error less than? Because as the sample size increases, population mean approaches the population mean. And what does the probability of x bar represent? It's the probability of getting a sample mean of 354 if the true population mean is 376. And why are we looking at the right side, right tail of the distribution? Actually, we're not. We're looking at the left tail. It diverges to the left. This is another thing I'm going to have to fix before you get it, but that should have said left tail. Okay, and we will see you in the next video.